Welcome to the podcast, an introduction to functions. Today what I want to do is introduce functions to you guys, kind of like what they are and the reasons why we have them. So a function is a way to relate two things together, a way to relate two variables together. And you're saying to yourself, well, Mr. Kemp, we already have that. We already have something called an equation. Y equals 3x plus 2. That relates my x and my y. I can, make a little graph on that. I can say as x gets bigger, y is going to get bigger. I can tell you by how much. It's a rate of 3. It starts out at 2. I can tell you all kinds of things about this relationship, which is true. And equations are cornerstone of algebra. But a function is a way to talk about a bunch of equations that kind of have the same variable. So y equals 5x, y equals 2x minus 7, y equals 8, x minus 1 half. And if I were to say, I want to compare these functions, I want to look at them and kind of compare them, talk about the different rates of change, it gets kind of cumbersome to do so, because I have to say, well, this first equation right here, this equation right here, it'd be like if I had a classroom full of students and I didn't have any names for my students. I just say, hey you, that guy over there in the blue shirt. So what mathematicians came up with is a naming system, a naming convention. And this name will take in part both the input and the output at the same time. So for this first equation, I might say, call the function f. My input is going to be x. So I say f of x equals 3x plus 2. My second equation might be g. So g of x equals 2x minus 7. My other equation is going to be h. h of x equals 5x. And my last one may be w. W of x equals 8x minus 1 half. Okay, so now if I were to say, hey, check out f of x, what's my rate of change for f of x? You could say, oh, that's 3. Which one of these functions has the greatest y-intercept? Oh, that would be f of x, because its intercept is 2. Which one has the smallest rate of change? Oh, that'd be g of x, because my rate of change is 2x minus 7. So it's a way to talk about different functions. Let's write that up. So reasons for functions. Reasons for functions. One is to name them, so we can talk, compare, contrast, all the information about them. The next reason why we have function is to be able to access complicated equations or expressions. Alright, so most of the functions or the equations we've dealt with so far have been pretty simple. We've had equations, y equals mx plus b, point slope form. We're going to do a little bit more complicated ones, but they're not going to get overly complicated. And that's good. We don't want them too complicated at our level. But sometimes we're going to want to access really complicated functions. If you've taken geometry already, or you're going to run into these sets of transcendental functions called trigonometric functions, called sine, cosine, and tangent. The way that these work, we set it up as a function, and we say sine of x equals something. And what we can do is just plug a number into our sine function, and it pops out a number for us, which is nice. If we were to calculate these long ways using algebra, the algebra looks something like this. It's called a continued fraction. Whatever x is, we put it in the spot right here. We divide that by 1 plus that number squared. We divide that by 2 times 3 minus the number squared plus 2 times 3 times that. You're seeing what's going on. And not only is this complicated, it goes on forever. I'm not going to get into the higher level mathematics of what's going on, but at some point it converges or it has an approximation, and that's where our calculators come in. So on our calculator, we can access this function, turn this on, by just using the function call. So I can say sine of 3 equals 1 point, so I can say 0.1411. So sine of 3 equals 0.1411 ... Now our calculator does a really good job at approximating, and I've mentioned that before. And for the most part, we don't need to know the exact number. Just like we don't need to know the exact number of pi, we just need a really good approximation for all the stuff that we need to do with it. Same thing with these functions. They give us really, really good approximations for it. Another one would be a logarithmic. So logarithmic of 3. Same thing. We can't. The math is highly complex. Here's the math right here. This is sigma notation. It says as n goes from 0 to infinity. We just keep on plugging in our value in here and keep on adding them all up and see what we get. Wow, would that be hard. So we go to our handy dandy calculator. We say log of 3 gives us 0.477. So log of 3 equals 0.477, right? So this idea that we can build functions that are more complicated than we can imagine and still be able to use them is awesome. We can do a lot of math this way. Think of it as kind of like a car. Like if you're a mechanic and you're going to work on a car. So I can draw a little car here. There's the bumper. Right, so we got our car. It's kind of a bad looking car. I don't know. And open up the hood, and let's say I had to, make every single part inside of my car. I had to build the carburetor from scratch. I had to build the engine from scratch. I had to process the tires and process all the seats, and that would be unbelievably hard for any one person to do. So instead, what we do is we buy these ready-made packages called parts, and so I can just buy an exhaust system and put it in my car. I can just buy these pieces and put them together, connect them all together, and then my car can run. I don't necessarily need to know how each individual piece works. I just need to know that they do what the job does that they're supposed to do. Which brings me to my third reason why I have functions. So the third reason I have function is because they're reliable. And that might sound strange that math sometimes is not reliable. What I mean by reliable in this sense is that every time I put something into my function, I'm always guaranteed the same thing out. So they're reliable. So for every input, I get the same output. Or I should say I get a unique output. And going back to my car, like I want to make sure that these parts are really reliable. So my car's not breaking down. So sometimes I put down gas in my car and it doesn't do what I thought it was going to do. If I connect my carburetor onto my car, I want to be guaranteed that yes, this part's going to work every time I want to use it. In math, I don't want to put 3 into my sine function, and then one day I'm going to do the sine of 3 and I get 1 or 0.1523. That would be bad. And there are relationships that's true. There's relationships that sometimes you put a number and you get one number, other times you put a number you'll get another number. So we say to functions, we're going to make you very reliable. We're going to limit your range to make sure that no matter what I put in, I always get the same thing out. So we're going to end this podcast. What I need from you is to write down these 3 questions, answer them, and bring them to class tomorrow. So 1, what are the 3 reasons we have functions? 2, rename this equation using function notation, y equals 10x minus 8. And lastly, let p of x equal 2x plus 5. What does p of 7 equal? Alrighty, I'll see you tomorrow.